So we are now on the second part of this lecture. As you will notice, all we're doing is repeating the same methodology that we have been using. We are using different units at this time. So the objectives that we're gonna have, given the grams of a compound, can you find the moles? Basically grams to moles, but now we're using the molar mass. And given the mass of the compound, can you find the number of molecules? That's the only difference we have now. So a problem like this, you have 38.2 grams of sodium chloride. Can you find the number of moles of molecules? Instead of moles of atoms, now you're finding the moles of molecules. And if we're dealing with an ionic compound, we don't say molecules, we say formula units, right? The most important part here is that you learn on chapter 5 how to name compounds. So now you're gonna have to use that. So we're gonna start with sodium chloride. That's gonna be sodium chloride. You have to know that it's not gonna be NaCl2. You have to know that it's NaCl based on what you learned on chapter 5. So sodium chloride, we have 38.2 grams of sodium chloride. Let's get used to always label everything. And you are being asked to find the number of moles. So moles of molecules of sodium chloride, or in this case, formula unit. So how are we gonna do that? Same as always. We don't care what units we're dealing with. We use the same methodology. I do not care about the grams because I'm looking for the moles, right? And when you look at this, what you have is molar mass. So the molar mass of sodium chloride is going to be 35.5 grams for the sodium, for the chlorine, I mean, and 23.0 grams per mole for the sodium, which is going to be 58.5 grams per mole. So that means 58.5 for every 1 mole. And then you do the calculation, which is going to be 38.2 times 1 divided by 58.5. So nothing new of what we did before. The only different thing, not new because you know how to do it, is that you have to know how to go from the name to the formula. You have to know how to go from the formula to the molar mass, and then this becomes your conversion factor, which is what we have in here, your conversion factor. So as you can see, now you definitely have to master chapter 5 before you can do these problems on chapter 6. Let's do another one. What about carbon dioxide? So once more, carbon dioxide. So 1 carbon dioxide, 2 oxygens. So molecular compounds, we use prefixes. And this is going to be 12.01 grams per mole for the carbon, plus 2 times 16.0 grams per mole for the oxygen. That's going to be 32 plus 12. That's going to be 44.01 grams per mole. So that's the only new part, which is not new, it's old because it's chapter 5, right? And then we're going to take 4.25 kilograms, and we want to find the moles of carbon dioxide. Train track connection. We do not want the kilograms because we want the moles, right? And immediately you say, yeah, I never seen that before. I never seen moles and kilograms. I always see moles and grams. So what does that tell you? You're not ready for this part. You're gonna go first to grams. once you get the grams, that's when you say, I do not want the grams because I want the moles. And that will give you what you need. So be aware of the units. Remember, the molar mass is grams per moles. So if you're beginning with kilograms, you better change that to gram first. And you know how to do that by canceling, right? So what's the relationship between grams and kilograms? 1 kilograms equals 10 to the third, or 1,000 grams. What's the relationship between grams and moles? That's molar mass, straight from the periodic table, which is what we have in here. So this is going to be 1 mole, 44.01. And then you do your calculation, which is going to be 4.25 times 1,000 times 1 divided by 1 divided by 44.01. And whatever your calculator gives you, put it in there. And based on these numbers, 3 significant figures, 4 significant figures, so your result will be 3 significant figures. So make sure you follow the rules of significant figures here, and especially during the lab in Science Interactive. And we're not going to do the other one. You have enough modeling right now to see how we do this problem. Let's move to the next one. The next one is going to be determine the mass. So we're going to be looking for mass, which is going to be in grams, because that is what we are using with the molar mass, right? So what are we given? We're given moles, millimoles, and kilomoles. So you're going to have to be careful with the units. So let's set up all these 3. Let's do the first one. Given 1.32 moles of carbon tetrafluoride, can you give me the grams? Well, what we're going to do, we do not want the moles, right? Because we want the grams. So this one goes straight into molar mass. So this is straight from the periodic table. So 1 mole of carbon tetrafluoride is going to be, carbon is 12.01, fluorine is times 4. So I do not know fluorine from memory. So let's solve that right away. Hey Siri, what is the atomic mass for fluorine?
The answer I found is 18.998.
So 19.0. So 19.0 times 4, that's going to be 76. 76 plus 12, 88.01. So it's going to be 88.01 grams per mole. And if by any chance that happens to be a little bit off, double check it on the periodic table. But the procedure is this procedure, right? We set up to cancel the moles, and that gives us the grams. Let's do the next one. The next one is going to be given 1.29 millimoles of carbon disulfide. Can you tell me how many grams of carbon disulfide this is going to be? So if you're having problems with the formula, make sure you review chapter 5. So I do not want the millimoles, right? Because I want the grams. And immediately we said, I haven't seen millimoles related to grams. I always see moles related to grams. So that means you are not ready for this part. You're going to have to go to moles first. So we get rid of the millimoles, we get the moles, and then we do not want the moles, right? Because we want the grams. And that's where we see, oh, now I see my molar mass. So relationship between millimoles and moles, 1 millimole, and milli means 10 to the minus 3, right? Relationship between grams and moles. 1 mole of carbon disulfide is going to be we have 1 carbon, so we got 12.01 grams per mole for the carbon, and the sulfur is 32, but it's going to be times 2. So once more, double check the periodic table in case I don't have it exactly. I do it from my memory, but I'm focused on showing you the procedure, not the math. So that's going to be 64 plus 12, which is going to be 76.01 grams per mole. So 1 mole equals 76.01 grams per mole. Once you put that in your calculator, you're going to get 1.29 times 10 to the minus 3 times 76.01 divided by anything at the bottom, divided by 1, which you really don't have to do, right? And that will give you your result. So once more, you have to have moles or you have to have grams. So whatever you start with, if it's not mole or grams, you have to change it to that first. So let's do the last one. The last one, you have 1.89 kilomoles, and given that, you're asked to find the gram. And we're talking about grams of sulfur trioxide. Sulfur trioxide. So we're going to get rid of the kilomoles. And you know that you're going to have to go to moles first. But you don't want moles, right? Because you want grams. And now we can do this. 1 kilomoles equals 1,000 moles, or 10 to the third. And we're talking about sulfur trioxide. So we're going to have 1 sulfur, 32.0 grams per mole. And 3 oxygens, which is going to be 48.0 grams per mole. Each oxygen is 16 times 3, 48. When we put all that together, that's going to be 80 grams per mole. 1 mole, 80.0 grams per mole. At this point, double check that everything cancels except what you need. And so far, so good. And then your calculation, what goes on the calculator is 1.89 times 1,000 times 80 divided by 1 divided by 1. And that will give you your answer. So that's how we go from moles or any variation of moles to the mass. Now let's stretch it out a little bit more. Excuse me. What happens if we are given the mass to find the number of molecules? Remember, a moles of elephant equals 6.02 10 to the 23rd elephants, right? A moles of atoms equals 6.02 10 to the 23rd atoms. So a mole of molecules equals 6.02 10 to the 23rd molecules. As simple as that. It's just an equality. So a mole of anything equals 6.02 times 10 to the 23rd of whatever you're talking about. In this case, we're talking molecules. So let's see how we do that. Given 3.5 grams of water, can you tell me how many molecules you have? If you notice, the number of whatever you're talking about only relates to the moles. So we're not given moles here, we're given grams, so we don't care about the grams because we need to find the moles, right? But once I find the moles, That's not what I care for because I'm looking for the number of molecules or how many molecules. So how do I do that? This one is molar mass, and water molar mass is 18.0, sorry. Water molar mass is 1 mole, 18.0 grams, right? Oxygen is 16, hydrogen is 1, so oxygen plus 2 hydrogens, 18.0 grams. So that leaves us with the moles, and when we look at moles and number of molecules, that's the Avogadro's number. Every time we're counting how many we have, is the Avogadro's number. So 1 mole of anything, on this case moles, is 6.02 10 to the 23rd. So for the calculator's purpose, 3.5 multiplied by 1 multiplied by the Avogadro's number divided by 18 divided by 1. Let's do the next one. Given 56.1 grams of nitrogen, can you tell me the number of molecules of nitrogen that we get? Once more, we don't care about the grams because we want the number of molecules, but we have to go through the mole first. Once we do that, we do not care about the moles because we want the number of molecules. So we're talking about nitrogen, N2, right? So 1 mole of that equals 28.0 grams, which is 14 plus 14. And 1 mole of anything, on this case molecules, is the Avogadro's number. So for the purpose of your calculator, 56.1 times 1 times the Avogadro's number divided by 28 divided by 1. And that will give you your result. Can we do it backwards? Given the number of molecules, can you give me the mass? But I want it specifically in milligrams. So let's find out. So given 1.8 times to the 17, 10 to the 17 molecules of sucrose, can you tell me the mass in milligrams? Well, let's find out. Can I do that? Let's see. Can I do that? Let's find out. So I do not want so these are molecules of sucrose, right? So I do not want the number of molecules of sucrose because I want the mass. But there's nothing that relates molecules to mass, so I'm gonna have to go to moles first. But then once I do that, I do not want the moles because I want the grams, right? But that's not really what I want because I do not want the grams, I want the milligrams. So you gotta take it step by step, right? So moles and molecules, Avogadro's number. 1 mole is always 6.02 10 to the 23rd. Grams and moles, we're talking about molar mass for sucrose. That's going to be 12 times 12.00, and these are going to be grams per mole, right? In addition to that, you're going to have 22 hydrogens times 1.0, and you're going to have 11 oxygens times 16.0. When you put that when you put all that together, that's gonna be, well, let's find out real quick. 144 plus 22 plus 16 times 11, which is gonna equal 342.0 grams per mole. So that's gonna be 1 mole equals 342.0. And then we have to find the relationship between milligrams and gram, right? So 1 milligram, I always like to put wherever the prefix is when I'm doing to the same unit, right? Whatever the prefix is, that's where I like to put my number 1. And then milli, which means 10 to the minus 3, that goes down here. So for the purpose of your calculator, you're gonna do 1.8 10 to the minus 17 multiplied by 1, multiplied by 342, multiplied by 1, divided by the Avogadro's number, divided by 1, divided by 10 to the minus 3, or 0.001. And that should get you your result, which should be at 2 significant figures. So now you're ready for your daily work. So everything we just covered so far, you should be able to do it on this table. So given the moles, can you find the mass? Given the moles, can you find the number of molecules? Given the mass, can you find the moles and then the number of molecules? Can you do it when we have prefixes involved? And so on and so on. So this table should give you enough practice for everything we did on this section. And with that said, we can say now that you know how to convert between grams of and moles for a compound, which is nothing more than knowing the molar mass of the compound. And you also know how to do it from mass all the way to the number of molecules. And that brings us to the end of this part. So next time we come together, we're gonna be going into part 6C, which is gonna be the same thing but going now deeper into the formula. Given a compound, can you do exactly what we just did, but can you do it for an element inside that compound? So that's next. See you later. Take care, stay safe, stay warm.